So thank you for coming here. So I'll present about this topic, plugin-based software architecture design with Ruby and RubyGems. So first of all, my name is Sadayuki Furuhashi. I was born in Japan and moved to the US 4 years ago. And now I live in Mountain in California. And I am a founder of this company called Treasure Data. So we are providing a cloud-based data management service. And you can collect data, store that, and you can query on it. And even if the data is so large, like hundreds of gigabytes per day, you can query smoothly. And for those data collection, we open sourced 2 projects. One is called Fluentd, one is called Embulk. And I originally designed those 2 projects. And I also personally created another project called MessageBack. I think this is almost 4 years, no, even more, 8 years. This is a serialization library. This is like JSON, but because this is binary based, it's faster and more compact. So I recommend if you know about this, and let's pre-check it. It's open source. So today's topic is this. So plugin architecture. So I think you imagine about those things. So this is Firefox add-ons. You can add add-ons to your browser to extend the functionalities. This is Eclipse Marketplace. You can add more plugins. And this is WordPress. You can see 5,000 of visits open source here, and you can click download and then extend your application. This is Apache Web Server. Mod proxy, etc. are downloadable. This is PostgreSQL plugin extension. So using plugin, let's say MySQL foreign data wrapper, you can plug in these extensions to PostgreSQL. Then PostgreSQL can run query on MySQL. So magically, even if you query on PostgreSQL, because PostgreSQL runs a query on MySQL, you can query on MySQL using PostgreSQL. So that kind of features are provided by plugins. This is Fluentd plugins. There are 300 or even more plugins released as open source projects. So benefits of plugin architecture is obviously a lot of features provided by developer communities. And even if you can add more features, you can keep the core simple. And because each plugins are isolated each other, it's easier to test each plugins. And because developers can easily join the community, likely you can get more active developer community, which is a very good thing and important thing as open source projects. If it's designed well, this is an important point. If it's designed well, we can get those benefits. However, if it's not designed well, we will get downsides only. So the point is how to design plugin architecture. But by the way, I think I'm still learning about this. So what I talked today is how I designed plugin architecture before. So this is today's topic. So first, I will talk about some design patterns of plugin architecture, and then talk about Fluentd, one open source project based on plugin architecture, and then the other open source project, Embulk. So after explaining about that, I will talk about some pitfalls and challenges. So let's start from this plugin architecture design patterns. So I think that there are 2 major design patterns for plugin-based software. One is traditional way, traditional extensible software architecture, and the other is plugin-based, purely plugin-based software architecture. So traditional extensible software is designed like this. So there's a host application, and that host application provides some extension points. And plugins add itself to those extension points. For example, you can add a loading interface, for example. For that, host application provides loading hook point or some kinds of callback. Then plugins can extend the functionality of the host application. But a difficulty here is that to add more flexibility, to add more hook points, you need to add more extension points to the host application itself. So to add more flexibility, the core application gets more complicated, which is not very good. However, this is easy to add the extensibility to an existent monolithic application. Another idea is like this. So there is a thin kernel, and almost all functionalities are implemented as plugins. Plugins talk to each other and form a sort of network to provide features. So in this case, the kernel itself is just a framework to implement plugins. The most of features are implemented as plugins. And good thing is that because almost everything are plugins, adding more flexibility does not mean more complexity of the core, because core is always a thin layer in application. But difficulty is that the application itself needs to be designed as modularized software. So it's hard to design. And often cases, it's difficult to optimize the performance. So loosely coupled API often conflicts with better performance. Then, how can we implement those purely plugin-based software? I think there are two ways for that. One is this, dependency injection. This is actually a well-known programming technique. How many people know about this dependency injection? Okay, thank you. So maybe half. So this technique implements a software using interfaces and classes. So this technique is often used in Java because interface and classes are specifically isolated. Then you replace interfaces with plugins, actual implementations. And you can optionally overwrite existing classes using plugins. So this is done by dependency injection containers. So that container gets a configuration file, which says this interface should be replaced by this plugin, this class should be overwritten by this plugin. Then when application runs, the DI container, dependency injection container, replaces the interfaces and classes. A good thing is that with this way, unit testing becomes very easy because each interface can be replaced using a configuration. So for example, you want to test that plugin, then replace the other plugins with dummy classes. Then everything are marked, excepting one thing. So you can specifically test the plugin easily. In Java, we can write this code to do dependency injection. So first you have interface, then it has a method. Then here, I would say this module uses an interface called store. Then store something. Here I need an argument here, anyway. Then from this class's point of view, implementation of this store is black boxed. So you don't have to know about the details. On the other hand, on runtime, it is okay to replace the implementation of this interface. So one example is to use this dummy store and this configuration. So this store interface should be replaced by dummy store class. Now you can also have another class here to change the behavior of this application. So this is purely modularized software. And actually, I want to do the same thing in Ruby, but honestly speaking, I don't know how to do this in Ruby. So if you know about this, please tell me. And by the way, I want to do this. Well, this is not done yet, but I want to do this. So my idea is to use a keyword argument here. And by default, it's dummy store. And but if you want to use another class here, this keyword argument should be bound with this another class. But then when you get the actual application, you get another instance here. And it should be able to nest the instances. So for example, you bound DB store here. And DB store uses another keyword argument here, and it gets sort of DBM here. Then store becomes DB store. DB store gets DB. DB becomes SQL. DB MPL, that kind of thing. So with this way, we can implement purely plugin-based software. And we adding more flexibility does not mean the complexity of the core, because you can technically replace any classes here. And I think another idea is to do dynamic plugin loading. So in this idea, there's a thin kernel, and there's another component called plugin loader. Then kernel asks this plugin loader to instantiate a plugin. Then this plugin also talks with plugin loader to create another plugin. Then eventually you will get network of plugins. Then the network of the plugins compose the application. And because you can use plugin to implement a plugin, you can build an ecosystem of plugins. So for example, this plugin uses this plugin, and they have different committers there. And once you add a new feature to another plugin, the other plugin automatically can use the new feature. So this is very good for open source projects. Then the final idea is to use both of them. So the one component, one application uses dependency injection at the core, then use also plugin loader to compose network plugins. Good thing is that plugin loader can be a plugin, right? Then it is also good for testing or extend the plugin loader itself, which is fun, right? Okay, then I talked about two things. So traditional extensible software architecture and plugin-based software architecture. Then for plugin-based software architecture, we can use dependency injection, dynamic plugin loader, and a combination of those. So for those, we need to think about trade-offs. So if you have an existing application, monolithic application, it's probably very difficult to change to use dependency injection, because by design, the application needs to use dependency injection. So at that case, you want to use traditional architecture, which is good enough. But if you design a new system, probably you want to use dependency injection and dynamic plugin loader. Okay, so those were the overviews of the plugin architecture. Then I will talk about an example, actual implementation I created. So Fluentd. So yes, so Fluentd is a data collector. So it collects data and then send them to somewhere else. If you think about syslog, it's similar, but Fluentd uses JSON as the log. So it's structured, and it's programmable. And you can add plugins to change the behavior. And the core is implemented in C, and plugins are implemented in Ruby. And it's used a lot, even in these environments. So it's production ready, of course. The problem was that if you have those inputs and outputs, you needed to write scripts for each combination. So you will get M by N plugins. which is almost, it becomes messy to manage. Then with plugins, you add one plugin to input a new system, and immediately the new input can copy the data to all of the outputs you have. Same thing happens for output. When you want to add another output, you just add a plugin, one single plugin. Don't add the same number of the input plugins. So then it's easy to manage the logs. This is an example configuration file. So this type means the name of plugin. So in this case, tail plugin reads a file. Then another plugin called forward. And then those logs from those sources matches one of those output plugins. So this is a network of plugins. And this is a meta plugin called copy. This plugin instantiates two plugins and copies the data to two outputs. In this case, one log goes to Elasticsearch and S3. So you can archive data, and you also can do search, real-time search on Elasticsearch. So simple log forwarding and complex forwarding is also supported using those flexible configuration. And you can also copy those data into two places. And this architecture is like this. So Fluentd core is very thin kernel. It provides only event router at the core. And the other things are implemented using plugins. And interesting here is that this plugin loader uses RubyGems to load plugins. So this plugin loader checks the installed gems. For example, if there is an Elasticsearch as a type, it looks at a file named Elasticsearch, then loads it. And if you want to install another plugin, just type gem install Fluentd plugin S3. Then it downloads a new plugin to RubyGems and installs. Then immediately it's, you can use it. So in this architecture, I use RubyGems as the plugin marketplace. So you can release new plugins to RubyGems. Then we can create ecosystem. So this is the code, actual code. So here, there's a method called search. So for example, this can be like S3 or Elasticsearch. Then for each load burst, it tries to require the file. But if it is not in load path, it goes to here. And it uses gem API. So gem : specification find all. It lists up all gem specification installed and iterates this block for each. Then if the path is included in the gem, use it. That architecture is simple. So I talked about Fluentd's plugin architecture. So it's plugin-based event collector, and it can take advantage of a lot of plugins released. So we succeeded to make the Fluentd core simple, because plugins do the other things, all the things. There are 300 of plugins released on RubyGems, and Fluentd uses gem API to load them. Okay, so this is another project called Embulk. Let's talk about this. So Embulk is an open source bulk data loader written in Java and Ruby. So Fluentd is designed for streaming data collection. Embulk is for batch. Well, this architecture is very similar to Fluentd because you have inputs and outputs. But only difference is that Embulk is designed for bulk operation, batch operation. Okay, let's see a demo. So here's Embulk installed. And for example, you have CSV file. This could be hundreds of gigabytes of data. And if you want to load this to PostgreSQL or Elasticsearch or other data, storages, it will take a lot of time. It's because CSV file can include some garbages, and you also need to handle those timestamp types or quoting like this, or null characters here. And as you can see, this column is actually timestamp, right? But the format is different from the previous column. This always happens. So how Embulk works is that first, you guess the format. So you pass as a configuration file and type guess. Okay, so it read the first part of the CSV file and guessed the contents. So first, apparently the file is compressed by the zip, and the character set is UTF-8, and the quoting character is double quotation, and null is probably null. Then timestamp format for this column is this format, but for next column, this format. And for example, well, this is one big cultural difference between Japan and the US. So in the US, we write the times format like this, right? For Japanese, it's weird. But for United States, this is even weird. So this could be mixed. Even in this case, if you use Embulk guess, this is guessed. So you don't have to worry about the details. And then let's confirm the result preview. Yes, timestamp is parsed correctly, and null was actually null. Then quoting is correctly processed. So this guessing is very important for bulk data loading, because if this guess is not available, you need to iterate. So you guess, you need to guess. Then try this configuration. Apparently, probably it's broken. Then try another configuration, then it's probably broken. Then again and again, you need to try, but it takes time. So Embulk solves it. So how it solves? It's plugins. So guess plugins, you can add guess plugins to guess the file formats, and it's extensible. So one real use case is like this. There's MySQL and Elasticsearch. You want to sync the data in MySQL and to Elasticsearch so that you can search those data. In this case, you can install Embulk input MySQL and Embulk output Elasticsearch. And interesting is that you can also add filter plugin to convert the structure. This Kuromoji filter plugin does text analysis to add some yomigana. I don't know how to say English, but it's a Japanese text processing. So not only data transfer, but you can also do enrichment of the data. And those all plugins are developed by 3 different people. They can collaborate using plugins on Embulk infrastructure. Other plugins like this. So you have a CSV file compressed on S3. Maybe it's hundreds of gigabits data. Then you use CSV parser plugin, JSP decoder plugins, and S3 input plugin. You also use output plugin for data analytics. Treasure data provides data analytics. So using this plugin, you can copy those data to make it queryable. There's also another plugin called BigQuery to put the data to BigQuery or Redshift. So another good thing of this plugin architecture is that executor is also a plugin. So guess is a plugin, input is a plugin, output is a plugin, and executor is also a plugin. Executor runs tasks in parallel. So for example, if you have hundreds of gigabytes data on S3, processing all data on a single machine takes too long time. Embulk executor MapReduce runs those tasks on Hadoop, which is a distributed computation environment. So those input plugins don't care about the execution environment because the executor takes care of it. Interface between here is loosely coupled. But with those combination, using Embulk's infrastructure, you can use existent all plugins on distributed environment. One use case is like this. Another use case is like this. So this is actually internal architecture of a treasure data. So we collect logs and provide query engine for you. Here is Embulk. So you post a configuration file to our REST API server, then Embulk runs there, and Embulk takes your data and load them into treasure data. It is a real use case. Okay, so here is actual architecture diagram of Embulk. So as I explained, there's guess and executor, and input and output. Very similar to Fluentd. But in input, you can also use file input, decoder, and parser separately. So one input plugin can be like input from database, like MySQL. Everything is in record format. But if you have CSV file compressed on S3, probably you want to use 3 plugins. Otherwise, you need to create a plugin for each combination, like CSV compressed input format for a 3 plugin. Well, it doesn't make sense, right? Instead, you want to use a 3 plugin, a zip plugin, and CSV parser plugin. Output is same. So you can format the plugin and encode the plugin and the output plugin separately, depending on the use case. This architecture is Embulk's plugin architecture. So as I said, Embulk is written in Java and Ruby. The core is using dependency injection. So for simplicity, there are only 2 components, plugin manager and plugin source. And plugin source is pluggable. So there are 2 implementations. One is injected plugin source, and the other is JRuby plugin loader. For Java-based plugins, well, you probably want to write Java. Then we use injected plugin source to load Java-based plugins. If you have Ruby-based plugins, use Ruby plugin loader. Then it creates a JRuby runtime and loads plugins there. And for this Ruby-based plugin loader, I used the same architecture with Fluentd. So it uses gem internal API to load gems. And this is a structure of a package. Well, this might be weird for you because it includes Java files and Ruby script. So to write a Java-based plugin, you write Java code, of course, there. S3 file input plugin.java. And you compile it into a Java file. You also need to depend on other plugins, other libraries. So for example, in this case, S3 file input plugin depends on S3 SDK and HTTP client library. So put all of them into class path directory. Then we also put another file, s3.rb. This file loads those Java files into Java VM. Then Embulk can use this plugin. So this is the actual procedure to load a plugin. So first, well, Embulk is Java plugin, so there's main method, of course. main method loads a Ruby script and then pass it to a JRuby runtime here. Well, interesting here that we can use this exclamation mark to load a Ruby file in a jar file. Then it loads JRuby runtime, and then immediately, well, in this JRuby script, we run option parser, and then load Java again to run the core. Then the core runs some core application, but it also needs to load plugins written in Ruby. Then use this JRuby internal API to call JRuby. Then this JRuby looks at class files, Java files in class path directory. Then again call Java to get the class loader to load the plugin. So that's the structure. Well, okay. Well, this is one hack I implemented in Embulk. So this is a way to execute Embulk. Embulk.jar, yes, example.yaml. Well, this is usually impossible because jar file is not executable. You need to use java.jar and then jar file. But this is possible in Embulk. Embulk.jar file has this header. Well, this looks weird, but actually this runs. So what's happening here? So this jar file is a shell script because the first line is empty. Then Linux kernel uses this as a shell script. So there's a command called colon, right, which does nothing. Then I use this here document to add some comments. Well, this is a comment, right? Then execute the Java file, -jar, and gives itself. This is also a batch file. Colon means comment. Then this weird thing is a comment. So this is a batch file. Then it exits here. So the others are just garbage. Don't care. This is also a jar file because jar file, which is actually zip format, ignores headers. So file entries are stored in footer. So having this comment in header is just okay. So finally, I will explain some challenges. So one big challenge is conflicts of libraries in plugins. So I want to load two plugins. One is a S3 plugin and one is Redshift plugin. So both of them depends on address SDK, but they depend on different versions. This can happen because they have different committers, different developers. So for this, I use this hack. So for each plugin, Embulk creates a new class loader. Class loader has isolated environment, so it is possible to load two different versions. But within JRuby runtime, conflict still happens. For example, there are two Ruby-based plugins. One is SFDC plugin, which loads data from Salesforce.com. There's another plugin called Marketer. They both depend on http-client.gem, but depends on different versions. Here, the version conflicts. So hopefully it works, but it might not work. Well, this conflict still also happens in Fluentd because Fluentd is just a JRuby application. So one plugin depends on Active Record 4.2, the other depends on 3.4, for example. Well, this plugin doesn't exist, so this is just example, but this conflict happens. So this problem is not solved yet. So hopefully I can create two separate environments within one JRuby runtime. So one idea is to create two JRuby runtimes within one JVM. But this is slow and consumes a lot of memory. So this problem is not solved yet. So wrapping up, I built Fluentd using plugin load architecture. So plugin calls plugins. So we could build an ecosystem of plugins. And Embulk uses dependency injection and dynamic plugin loader. And it uses JRuby to implement plugins, but uses Java for performance of the core. And because Java VM can load nested class loaders, it can load multiple versions of plugins within a single environment. But still, the version conflict within a single Ruby VM is not solved, and performance is also a problem. So what's next? So please build your own application using plugin architecture. And tell me how you did so that I can learn. And I'm also doing some other projects. And one is distributed workflow engine using Java VM plus Python. Okay. Thank you very much.